Good morning, everyone. So today we're going to start by checking our answers from yesterday. So I've got problems 1 and 2 here, and I'm just going to run quickly through just the system of equations part. So if I wanted to solve this system, I can choose any method I want, whether it's graphing, substitution, or elimination. I'm going to choose to do substitution, and that's because v and t are already both pretty close to being by themselves. So what I'm going to do is I'm going to solve for v by subtracting t from both sides. So I have v is equal to 7 minus t. Now, remember that this is especially useful because at this point I can now replace any v's I see in my other equation with 7 minus t, and that means that I will have only t values in the equation and can solve it. So I'm going to write out this equation using my substitution there. And just remember that instead of v, write that 7 minus t. Okay, so now I'm going to solve this with some simplification and some distributing here. 7 times 200 gives us 1400 minus, well, this is going to be 200 times t, so 200t plus 300t, and all of this still equals 1600. So subtract 1400 from both sides, and I'm actually at the same time going to just combine these two, giving me negative 200 plus 300, which is 100t. If you got 500t, just watch your negative here, you might have dropped that. So I get 100t here, and I'm going to subtract 1400 from both sides. That's going to leave me with 200 over here is equal to, these cancel out, 100t. And since 100t is just 100 times t, I can undo that multiplication with division, and that leaves me with t is equal to 2. Since t equals 2, and 7 minus 2 is 5, that tells me that v has to equal 5. I could put that back in and it would work. This is telling me that the two violins I sold, two of the violins I sold were for $300 each, and the other 5 were the $200 ones. Okay, let's solve the second equation that we have here, and that one was the one with the admission fee at the small fair. So when I'm solving this one, I'm again going to use substitution simply because these terms are almost by themselves already. And I'm going to subtract a from both sides. So this gives me c is equal to 2,200 minus a. Again, I'm going to go back up and I'm going to substitute it into the equation that I have not so far changed. And everywhere I see a c, I'm going to write 2,200 a minus a. So I've got 150 times my substituted value plus 4a is equal to that $5,050. Put in your substituted value and go ahead then and solve. Remember that we need to get rid of parentheses first since they trap numbers in place. So I've got 150 times 2,200, and that gives me 3,300, and then 150 times a, 1.5 times a, plus 4a is equal to 5,050. Combining my like terms here, I can get my a's together, and this is going to give me a 2.5a is equal to 5,050. And don't forget, we still have the 3,300 in front of that being added to it. Subtracting 3,300 from both sides will take us at least a step closer, and we end up with 2.5a is equal to, let's see, 1,750. Dividing both sides by 2.5 is going to give us a final answer of A is equal to 700. Now that I know what A is, I can substitute that into my equation, and I'm going to choose this easy equation here using the 2,200 minus my 700, and that will give me a final answer of C, children's tickets, at 1,500. So apparently there are way more kids than adults, so each adult had, well, at least 2 kids, on average a little bit over that, so that's going to be a crazy fair. Well, what we're going to do now, though, is we're going to look at some new equations and do a few more word problems before I give you guys some practice. These are the sorts of word problems, this one that we're about to do, that I end up actually doing a lot. And I do these when I'm budgeting, whether it's for a trip like this one, or for my daily life when I'm looking at companies that I'm going to use, insurance, really almost anything. Anytime I have a couple options to choose from, I can figure out what each option will cost, when options will break even, and whether or not it's going to be worth putting my money into certain companies versus other ones. So let's go with this first one to kind of see how that works. And I really encourage you to do this in your own life as you start to take more and more care of your finances rather than relying on your parents for that part. So you're going on a trip. You have the option of 2 different cars to rent. One car has a down payment of $50 and charges $25 each day it is used. Another car requires a down payment of $10 but charges $30 each day it is used. When will the cost for the 2 cars be equal, and which one will be the better deal before that day, and which one will be better after? Now these are just random numbers, but we can work out the idea behind the problem here. Remember that when you're trying to set up an equation, you're going to kind of look at the 2 different totals that you have. Here, were I to choose this option, the total cost I do not know, because I don't know how many days I'm gone. But I could tell you that that unknown total would be equal to something to do with these numbers. So if I wanted to find how much I'd spend here, I'd say, well, okay, I have a down payment of $50 and a $25 charge each day. I know that when I'm talking about each day, that means that this is a rate of change, and as we like to call it, a slope. And I'm going to pay that repeatedly. So that means I'm doing 25 times the number of days I'm gone. And this other number, 50, is just a starting amount. We pay it one time and we are done. So that means I'm just going to add that. That would be an intercept. And so I end up with a slope-intercept formula using different variables. I use t for total spent and d for days. And I'm just going to jot that off to the side, because it's good to remember what your variables stand for so that you can kind of like retranslate this back to English at the end of a problem. So that's my first one. And if I was just going to go with this for this formula and this company, I wouldn't really have to go any further. But there's another option for car rentals. And in this one, the car requires a down payment of $10 but charges $30 every day it is used. So this is an entirely different total. If I went with this company, it wouldn't look the same at all. But my total would end up being, well, a down payment of $10, so that means I'm just adding that $10 because I only pay that once, and $30 each day. So again, I have that 30 that I'm spending repeatedly. So now I have these 2 options, and I want to know, when will it not matter which one I choose? Well, if I think about that, that's just saying when will they end up costing the exact same amount. So really what I'm saying is t would have to be equal, and so would d. And I can figure out that by just saying, well, if I know that t is equal to 25d plus 50, can't I just set that equal to 30d plus 10? Because those amounts are the same. So I'm going to write that out, and I can solve it from there. So here, what I'm going to start with is I'm just going to get all of my like terms combined. Now here I am switching sides, so that means that I'm going to have to undo order of operations. So I'm going to subtract 25D. This is going to ensure that now all of my D's are combined, leaving me with 5D plus 10 and 50 on the other side. Now I'm going to get my other like terms together by subtracting 10 from both sides. That leaves me with 5D is equal to 40. And dividing both sides by 5, I am left with D is equal to 40 divided by 5, or 8. Now remember, D stands for days. So at D days, or 8 days, our totals are going to be the same. And I could work out what the total is, but the question doesn't actually ask that. The question asks, when will the two cars be equal, like in terms of the money spent? Well, at 8 days, it doesn't matter what company I spent money on. The second question, though, is interesting because you can actually do this without doing any specific math. I want to know which one would be better deal if I stayed like 7 days, and which one would be better after those 8 days had passed. I can solve this one of two ways. I can either put in a number less than 8, solve this equation and see what my total would be. So I do 25 maybe times 6 plus 50, and then 30 times 6 plus 10, and see which one would be cheaper. But you don't actually have to go that far, because consider what these numbers mean. If I'm spending $25 a day here, it's cheaper than spending $30 a day. But it does cost more on the front end. So what that means is you're going to spend more on this first equation initially. So that first company will cost more initially because of that $50 you spend, versus this one, which will be cheaper initially. Each day you're there, though, you spend less with this one than you do with this. So eventually this will be the cheaper option. And that's actually always going to be true. If you're looking for which one will be better, low slopes will cost less in the long run. So eventually this one would be cheaper. In fact, this one would be cheaper at 9 days. Anything past that 8 days, it will be cheaper. And this one, though, if you're only staying for 6 days, it doesn't make sense to pay the extra dollar just because you're spending less per day, because you'll save money by not having to spend that initial high cost at the beginning. And that principle is a really good one to keep in mind. Some people apply it to things like boots. If you buy a really good pair of like steel-toed boots or winter boots or anything like that, they tend to last a long time. So it costs a lot on the short end, but if they are not replaced, you can save money by never having to buy another pair of boots. Of course, for other people, it's not worth it because maybe they replace their boots a lot, or they tend to lose or break things, so they're going to pay it repeatedly regardless. So it's better off for them to buy a cheaper pair of boots. So there are lots of things to consider with finances, but knowing what you can do to compare options and save money in the long run versus investing smaller amounts short term can be important. I'm going to stop there, and we are going to get a bunch of practice problems tomorrow with word problems. And you guys are going to have some time tomorrow and on Monday to ask questions on that. For today, this is all you have to do. Just drop in the comment section of the homework for today, drop whether or not you got the first 2 problems right, the ones that we did at the beginning of this video. Just tell me if those were what you got, the 700 and 150 and the 2 and 5 from the problem above. Thank you all, and have a great day.